And lastly, this quiz will cover section 5, which was all about our properties of logs. So we've got 3 main properties, our product, quotient, and power rules. We need to be able to use those to expand and condense our logarithmic expressions. Lastly, you'll need to be able to use your change of base formula to evaluate logs with different bases. So number 9, use the properties of logs to expand each of the following. So we have the log of 2 things being multiplied together. That tells us we want to use our product property. Well, our product property says that the log of a product is the log of one plus the log of the other. Now from here, we've got the log base 3 of 9. We can evaluate that and make it a nice looking number. If I had log base 3 of 9 equal to x, and we would log loop it, 3 to the x equals 9, oh, x is 2. So we can swap out that entire log base 3 of 9 with just 2. So our final answer then is that 2 plus log base 3 of x. In B, same idea, we just have our quotient property at play, which is going to be the log of your numerator, base 2, same base, minus the log of your denominator. Now we can't reduce log base 2 of y, but our log base 2 of 32 we are going to be able to evaluate. So if I have log base 2 of 32, I can set it equal to x, log loop it, and say 2 to what power gets me 32? Oh, 2 to the 5th is 32. So we swap out log base 2 of 32 with 5. So then our final answer, we just have log base 2 of y minus 5. In C, we've got something in our exponent, which tells us we are going to use our power property. Your power property says bring that exponent on front. So we'll have m times log base 7 of 49. Wait a minute, 7 and 49, those numbers go together. Because if I were to evaluate this, log base 7 of 49, we set it equal to x and we log loop. 7 to what power gets me 49? Oh, that's 2. So log base 7 of 49 is just 2. So now I've got m times 2, or usually 2m. In example D, we don't really see any power or any properties at first, but what we need to remember is that the cubed root of x can be rewritten as x to the 1/3 power. So then all of a sudden we've got a power property, we can bring that 1/3 out front. So I've got the 1/3 times log base 2 of just x would be left over. Oops. This we won't be able to simplify any further, so we'll call it good right there. Last one that I'm going to walk through, be sure to check your answer to the challenge problem because that's a good practice, but I won't take the time to walk through it. It's just a combination of all our power, quotient, and product properties for logarithms. So example E, though, we can work through that. So I've got a numerator and a denominator, so I'm going to take the log with the same base of my numerator, 25x to the 7th, minus log of my denominator based on my quotient property. I can't simplify log base 5 anymore, so he's just going to keep coming down. But I do have the log of a product. Well, there goes my product property. So we split that up with addition. Log base 5 of 25 plus log base 5 of x to the 7th. Minus that log base 5 of y. That's not going anywhere. Here's a couple more steps. We have the log base 5 of 25. If we were asked to evaluate that, we would log loop it. So log base 5 of 25. We don't know what it's equal to. We'll call it x. We log loop it. 5 to the x is 25. Oh, 5 squared is 25. So log base 5 of 25 is just 2. Then we've got the log of something with a power. We can move that 7 out front. So plus 7 times log base 5 of x minus log base 5 of y. There's our final answer. Now be careful that you don't try to move that 7th power out front at the very beginning, because it has to be where everything is taken to that power. But the only thing that the 7th exponent applies to is just that x, not our 25. Moving it out front before we break that apart using our product property would be incorrect.